Alright, I believe I'm recording. Let's take a look at this problem. We have three equations in three unknowns. They refer to that as a system of equations. Each of these represents a line in three-dimensional space. The type of problems that we've looked at in class is where these three lines intersect at a unique point. The method that we are going to use to solve these 3x3 systems is method of elimination. So we need to pick a variable to eliminate through linear combinations of the other equations. What I typically do, I will look through and see if I have a coefficient of 1 in these equations and pick that variable to eliminate, because it will be easy to make that coefficient equal and opposite any other coefficient if I want to eliminate that variable. So in this case, the y's jump out at me as an easier. You could eliminate the x's if you'd like to. You can eliminate the z's if you'd like to. But if you choose the y's, I think you'll find it less work to eliminate the y variables, the y variable. So let's start out by simply adding equation one. Well, let's number my equations 1, 2, and 3. And let's add equations 3 and 1. Yeah, 1 and 3. I'm going to take equation 3 and write it down exactly like it is, and I'm going to add equation 1. And this coefficient is a positive 1, this is a negative 1, they're equal and opposite, and they will be eliminated when I add those equations together. So I've got 4x plus y minus 6z is equal to 30. Be careful that you don't jump and copy down another portion of an equation, that you mix and match the equations. I often do that. Number one, you'll hear me in class say, hey, did I copy that down right? Because I know that I'm prone to that mistake. So to help me not make that mistake, I just try to check myself often. Now, I have equation 3 and equation, I guess it's not, I have it written up here, it's not necessary that I write it right there, I guess. Alright, so let's add these equations together. It's often convenient for students to put coefficients of 1 in front of those variables. I've got 4x, take away 5x, and negative 1x. The y's are eliminated, that's what I wanted to happen. And a negative 6z plus a 4z is negative 2z. And adding these together, I get 1. So I'm going to label this equation 4. Let's shrink this up just a little bit. So now I have one equation in two variables. I need a second equation in two variables. So I'm still going to eliminate y. Last time I did not use equation 2, so this time I have to use equation 2. So it has a positive 3. I look up to equation 1 and I can easily make that a negative 3 for equal and opposite. So I'm going to take equation 2 and I'm going to add to it 3 times equation 1. So if we copy equation 2 as is, then for equation 1, I'm going to multiply everything by 3. So I've got a negative 15, negative 3y that I wanted, and I'm multiplying by 3 at 12. And at a negative 87, I better check myself. Where's my calculator? I love this calculator. So, turn it on. 3 times my equation 1, my negative 29. Negative 87. Okay. Add these equations together. The y's are eliminated. I have 17z, negative 97. Alright. Let's label that equation 5. And let's come over and select well, it's going to select the whole thing, so we're going to copy this to another page, give ourselves a little bit more room. I'll erase what I don't need. Let's make that bigger so that I don't want to erase my equation. Maybe I'll make the size of my eraser a little bit smaller. Alright, so there's equation 4. And that's grouped together, and let's move it up here. Let's go get equation 5. And it's selected it fine. Alright. So we have a choice here. Do we want to eliminate the variable x or the variable z? And again, I typically look for a coefficient of 1 because, or negative 1, because I can then easily manipulate that negative 1 to be a positive 21 and eliminate the x. And that's what I'm going to do. I'm going to eliminate x by taking equation 5 and adding to it negative 21, because a negative times a negative will be positive, equation 4. So if I write equation 5 as is, and now everybody in equation, every term in equation 4 gets multiplied by a negative 21. So that becomes a 21x, negative times negative, that becomes positive, and see, my eyes for a second, I jumped to equation 5. When I multiply by 1, that's a lot easier than taking negative 21 times the negative 27. Alright, these cancel, and I have 59, and over here I have negative 118. If I've added those right, I am going to double check, well, move my calculator over, double check it just for you to make sure that I don't confuse anybody more than necessary. Hey, and that's what I have. Now, we want to divide that by a 59 and get a negative 2, right? Yeah. Okay. Now, I want to use the system of equations immediately before this in order to solve for the other variable. Through substitution, I'm going to replace z with negative 2 and solve the equation for x. So I'm going to do that with equation 4. If I write down equation 4, I've got negative 1x minus 2z, but I'm going to replace z with a negative 2, and that was from equation 4. Now I have one equation and one unknown, and I can solve for that. Negative times negative is positive, and that's 4. We want to subtract that, and 1 minus 4 is a negative 3. So x is equal to positive 3. Alright, now I have x, I have z, I need y. I need to go back to my original equation that had all 3 variables and pick one of these equations to solve through substitution to get y. So I'm either going to use equation 1 or equation 3. It really doesn't matter. So let's use equation 1. I've got negative 5 times x, where x is 3. I've got the opposite of y, and that's what I'm trying to find out what y is, plus 4 times z. And the claim in equation 1 is that that's equal to negative 29. Alright, so this guy is a negative 15. The negative 15 and a negative 8 is a negative 23. If I add that, I get a negative 6. So I'm getting that y is equal to 6. So my solution, my ordered triple, x was 3, y is 6, and we found z to be negative 2. When we say order, order is important, and typically with x, y, and z, that's how they define the order of these. Sometimes you'll have problems where they have A, B, and C, or M, N, and Q, or 3 other letters, and you'll have the freedom to define the order. So it's a good habit to write down the variables, the order before the coordinates of your point. All right, let's take a look at this second problem. We've got a quadratic equation. The degree is 2, and we have a line here. So this is different than the first problem. We could have 3 possibilities here. Since this is negative, this would be a parabola that opens downward, and hopefully this line will intersect that in 2 places. That's the type of problems that we saw in homework. That was my intention to quiz you. On version 2 of this quiz, however, I have made a sign error in typing in the problem, I believe, and I had a situation where the line didn't cross the parabola at all. Was a no solution case. We did not practice that, and colleges may consider that fair game, and oftentimes if they've talked about it and you haven't seen it, it's a good thing to study because they'll put it on there. But I'm not going to do that. What I'm looking to see is, did you pay attention in class on the problems that we did? Did you do your homework? Did you study that material? And are you prepared to do similar problems on quizzes and tests? So if you don't see it in class, or I suppose at worst I would make it like a bonus problem if it was something that you had to think a little bit outside of the box. We did talk about this briefly, but I don't know if I was consistent in every class in talking the same length about it, and like I say, I did not intend to have that on a quiz. Alright, so it's possible that the line could come in here and touch that one place, but the intention was for it to intersect at 2 places, and for you to find the 2 points of intersection and give the x coordinate and the y coordinate for each point. Alright, so let's take a look and see what. Now, we're going to do this by substitution, because if we try to eliminate, we don't have a squared term in this line that will cancel that. We won't be able to solve this by elimination. We're going to have to use substitution. And the way it's set up is perfect for substitution. I'm going to label these equations 1 and 2. And I'm going to substitute equation 2 into equation 1. So if I were to copy equation 1 exactly as it is, I've got y is equal to the opposite of x squared minus 6x minus 10. But since y is equivalent to 2x minus 3, I can replace y with 2x minus 3. And now we have a quadratic equation, and that quadratic equation, we're familiar with solving it. We know that the quadratic formula is the king of solving this equation, that you can always get the answer through the quadratic equation. And you can always get the answer through completing the square, because that was how you derived the quadratic equation. But ideally, most of the time, to tell you the truth, we look first to see if we can factor it, because generally that's an easier solution, or at least a faster solution for most people, for most students. So I'm going to move these other 2 terms to the right-hand side. I'll subtract 2x from each side. I'll add 3 to each side. Oops. And since all of these are negative, I'm going to multiply both sides of the equation by -1. When I multiply -1 times 0, it becomes 0. So I can change all of these terms and take their opposites since they were all negative. Now, let's try to factor this, and it looks to me as it does factor that I have x plus 7 times x plus 1. There's 2 numbers that multiply together to give you the constant term, add together to give you that middle term. The factoring is generally easiest when that leading coefficient is a 1, or at least if it's a prime number. You don't necessarily have to come over and do the x method on problems like this, because your x is always going to be those two numbers that we just said, two numbers that multiply together to give you the 7x, but add to give you the 8x. Well, you just use the coefficients, the 7 and the 1, because this leading coefficient is 1. You don't have to come down and construct a table and try and factor it. It's easy. You just write down those values. Now we have a zero product theorem that says if you have two numbers that multiply together to give you 0, that one or both of those numbers is 0. So I typically skip over this step at this point. I typically do not write x plus 7 equals 0 or x plus 1 equals 0, because at your level it's pretty obvious that negative 7 and positive 7 add to give you 0. Now, this is not my final answer. Remember that we're trying to find the x and y for this point and the x and y for that point. All we've done at this point is we have found the x of each point, and we now want to find the y. Well, that second equation is the easiest way to find the y. We could use the top equation if you really want to go through that arithmetic, but I'm just going to double that and then subtract 3. If I double that, I get negative 14 minus 3, I get a negative 17. If I double this, I get a negative 2 minus 3, I get a negative 5. So negative 7 comma negative 17 is one point, negative 1 comma negative 5 is the other. So we want to tell people that's our solution. That we have a point. I'll have to write them right on top of each other because I ran out of room. That, and it is a smart idea to write it down as x comma y equals the coordinates of your point, to not just leave it separately like this, because yes, those are the numerical values, but you're indicating in your solution here that it is a point, that the order is important in an ordered pair. So I had made a mistake. There was 4 versions on the quiz. On version 2 of the quiz, I made a typo. Like if I had made that a positive 3, I made a sign error in typing it, and it made this line not intersect that parabola. So in our retake, ideally when we do retakes, I'm going to have you guys come in before or after school, but I made the mistake on that one version, and so I'm not going to. Our retake is going to be in class, and we'll talk about that on Monday. And I apologize if you're watching these other videos just because you had some problems with that. I apologize for that. All right, so let's stop here, and I have a last version to create on these videos, and then I'll have the solutions to all 4 versions. I hope that this helps, and I will talk to you later.